Thank you for being here, Mr. Buffett. Can you tell us a joke?
Why don't scientists trust atoms? Because they make up everything.
Hi there, welcome back to Uncle B Studio, where you learn how to act like a grandpa but code like a pro. Thank you for that exclusive interview, Mr. Buffett. Unfortunately, Mr. Buffett is very busy and we have to let him go. Maybe we'll talk about how to implement this lip sync model, i.e., invite Mr. Buffett back. And if you guys want to know how, comment below and maybe we can cover it in the later video. And in the last video, we're able to deploy a web application where you can ask Mr. Buffett questions. Although in the last version, Mr. Buffett was only able to answer one question at a time, so you can't really have a conversation with him. And we will change that today. So step number one, let's take a look at the architecture diagrams here. There's three things we want to accomplish today. One is we want to leverage OpenAI's chat completion API. So our model would generate messages based on our conversation history. Number two, we want to list out the references so the user can actually watch the annual meeting clips or investor letters, etc. directly. Number three, we want to store the parsed annual meeting transcript or any other type of transcript in a vector database, so then it makes it easier to parse other type of data, things like annual letters, shareholder letters, 13Fs, the company's 10K and 10Q, etc. As the data grow larger. And in terms of architecture, we're gonna create a chatbot class, and then we're gonna set up the initial prompt messages in the chatbot class. And then we're going to store all the conversation history within the chatbot class. At the same time, we are sending the overall chat history from the front end to the instantiated object. And then what it would do is take the latest user message, do a vector search in our vector database. In this case, we're using Milvus. And then add the results, append the results as context back to the OpenAI chat completion, and then get the results back and display it on the front end. Before we go any further, let's take a look at how it will look like when we finish the project. So you can ask Mr. Buffett. So now you can actually have a conversation with Mr. Buffett instead of just a simple Q&A. And one of the new features we've added, you can see the reference where this is the annual meeting when he talked about the same topics. So you can actually bring up the URLs. It's either a video recording with the transcript or a document that's showing where Mr. Buffett actually talked about a topic. Okay, step number two. Let's talk about the chat completion APIs from OpenAI. Let's first try to understand how the API works. Essentially, the function, the API takes in a list of messages. There's three types of messages: system, user, and the assistant. System basically tell the assistant a list of instructions to follow, and it sets the behavior of the assistants. And user, these are basically user messages, either asking questions or sending instructions. And assistant, this is basically a model, and its job is to respond to users' requests or instructions according to the behavior that are set forth by the system message. It's also important to keep the history of the message because the user can actually ask follow-up questions where the question will only make sense in the context of the previous conversations. Okay, now let's take a look at the code. We have a function called chat message list. Essentially is what we use to call the OpenAI's chat completion APIs by passing in a message list. In this case, it's a list of dictionaries, which is a list of messages. And then we're calling this function by constructing a list of messages. Now, the list of messages where we search a vector database, find the context that we need for each of the questions. Step number 3, let's talk about vector search databases. In the previous version of our model, we're storing data in a pickle file, and we placed it in the backend servers, and that's how we're accessing the information, which, in AI terms, this is considered long-term memories for the AI models. But in the real-world application, as the size of the data grows, we want to use a dedicated vector database, and there are several options available. So, for example, there's Pinecone. This is the most popular, and there's a lot of features the other ones don't have. Things like metadata filterings that can build the queries a lot more efficient. But currently, there is a waitlist for the free version of the trial, and you can always use Redis. Redis is a memory data storage. This is usually used for cache management, but you can also use for sort of vector search. And Milvus, this is very similar to Pinecone, and this is what we're going to use for this demo. There's the self-hosted solutions where you can actually deploy it on Kubernetes clusters, or use a managed solutions like Zilla's Cloud. This is what we're going to do here for simplicity. Last but not least, you can also use Vaviate. So it's very similar to Pinecone and Milvus. But the query seems to be flexible, and especially if you're already familiar with GraphQL, I would definitely recommend these options. If you guys want me to cover each of the vector database in terms of architectures and technologies and details, leave the comment below, and we can do an episode. One thing I want to point out about vector database is that vector database serves one purpose. It's fast search based on vectorized information to find the closest match. This is usually used in a machine learning operation setting, and it should not replace the traditional databases where consistencies, transaction integrities, and schema relationships usually needs to be enforced. So let's talk about setup of the Milvus vector database. First of all, you go to Zilla's offering, and then you log in. You should get about $100 credits where you can try out things for free, and then you can create a database. And then in the database, once it's created, you can try to connect it using Python and following this connection guide. Obviously, there's some sample code here in this repos. But the sample code itself is pretty straightforward, so you might want to follow the actual documentations for detail. Next, we need to talk about how to import a database. First, we need to create some sort of collections. And the collections, similar to a relational database, has its own schemas. This is very similar in the sense that you have to define the what columns or fields are available, and also the data type for the fields. Now, the one thing that's very different is what we call the flow vector field types, and this is where we're going to put our embeddings. And there is a dimension parameter which we need to show. We need to specify what the dimension is, and for all the OpenAI embeddings, the dimension is 1536. So the easiest way to import data is to use code. So I'm going to show you the Python code real quick. We have a module called dbvectors, and then in there we have a function called insert data to Milvus. This will convert the pickle file that we have and create the collection and insert the data into our vector database. Essentially what we need to do is that we need to create a schema. We need to create a collection, assign different fields, and then assign the types of different fields. If you're familiar with relational databases, it's very, very similar. And then once the collection is created, we have to create an index. Now, the index, like other database technologies, index basically makes our query speed a lot faster. And the main difference here is that there's a parameter called metric types. There are two metric types we can use. One is L2, which is the Euclidean distance. Second is IP, IP stands for inner product, which in our case is a dot product. And these metrics are being used to calculate the distance between the input vectors and the vectors that are already stored in a database. And we explained it in previous videos. For our case, for our scenario, it doesn't really matter which one we use. Now, once you learn how to insert the data into a database, querying from the database is very similar. So in this case, we can take a look at DB search functions. Essentially, we find the collection that we've created here. And then what we're going to do is we're going to call the search functions from that collections. And then we're going to pass in the search parameters, which in this case, we're basically specifying we're using metric type L2. And then there is a parameter called limit, which returns you X number of results. And we do have a parameter that goes into the function called top n, which only returns the top n closest results from the question. The top n parameter can also be used to return multiple conversations Warren Buffett may have had, and we can actually give it updated view based on timestamp of the interview or the transcript, which we'll explore in later videos. Now, to see this in actions, if you have everything set up, you can run the functions and get the results being stored in a database. Now we can go back to the completion code, call the DB search function, get the result context back, and then turn this into a user message, and then pass this user message back to the OpenAPI calls, and then finally return the resulting message, which is now a system message, back to the caller. Now we should test our code locally before we deploy it to the backend. To do that, fairly straightforward. Bring up our command prompt. We run our applications. This will start a Flag server locally, and then we have to modify. Our API clients a little bit to make sure that we're passing in a list of dictionaries, and then return the results. So if we run this, we should get our results back. And once this is done, we can safely deploy this new backend code to our backend servers in Heroku. In step number 4, let's update our UX UI code. So let me bring up the UX UI code. In here, let's talk a little bit about the React component we have. We have a React component called Chat, which is a functional component. We'll talk about that stuff in the later video if you guys are interested in. But it takes in a whole bunch of different props, and then onSend is one of the prop. In this case, onSend is essentially a event handler for when the button component is clicked. And the handle send function is where we send the HTTP request to our backend and parse the results. So a couple of changes here is that, one, when we passed in our messages to the backend instead of single message, now we're passing in all of the message histories to the backend. And 2, because we're sending the references back from the web service as well, now we can actually change the attribute of an object called message, and then update its reference. So if you look at the message interface, now there's an additional property called reference. There are a couple of other changes we have to make on the front end, but I'm not going to go into details. You can see it from the latest repo. But now, once the changes are made, we can actually test the front end as well. So if you bring up your command prompt, and then you can do a test. You can actually run the Vercel functions, Vercel def, which compile all your Next.js/TypeScript code and then run it on your local servers on your local host port 3000, and then you can actually bring up the UX UI yourself and start testing the results. That's it, guys. Now you can actually have a conversation with Mr. Buffett. We actually have a lot more planned as we exploring adding new features and additional data to our vector database. And these actually include things like your annual letter to the shareholders, the 13 Fs, which have like the Berkshire Hathaway's holdings, and also 10Q and 10K for each of the companies that Berkshire Hathaway invested in. And then also to make the data more live, we're going to parse through news articles, interview on invested companies, the invested companies' earnings calls, etc. And ultimately, what we want to do is that with enough data available, we can actually let Warren Buffett recommend a stock based on the fundamental information available of the company. And we will also actually explore how we can use autogpt to make our life easier, especially when it comes down to parsing PDFs or other type of data formats. Thank you for making it to the end, and I'll see you soon.